When we want to use an IPv6 address, we need to configure it like we do with IPv4. With IPv4, my client machines typically use DHCP. The routers, we would actually configure the interface directly. With IPv6, you think the process is much different? It actually isn't. It's done the same exact way. We did add one feature that allows us to discover what network we're on and do our configuration that way. But IPv6 configuration, just like IPv4. So the first way we would configure an IPv6 address, static or manual. Where we would go right into the configuration screen, like on a router, we go to the interface. We would do IPv6 address and then specify what the IPv6 address is. On a computer, a PC, a Linux box, a printer, we would go into whatever the network configuration box is, find the network interface, find the interface card, find out wherever you configure IP addresses. Look for the specific IPv6 address space. Knowing that it's what we call dual stacked. There's an IPv4 address and an IPv6 address. You can't just put the v4 address in the v6 slot or the other way around because they're separate processes. They have to go in the appropriate location. But either way, we can do it statically, manually, or we can do it dynamically. So in IPv4, we always use DHCP, Dynamic Host Configuration Protocol. This is a fully automatic way to do it. And so what happens with DHCP is the device goes out and does a broadcast, hey, DHCP server, I need an address. The DHCP server responds back. Well, if you remember, we were talking about this earlier, that IPv6 doesn't do broadcasting. So how does it do a DHCP discover? Well, it uses multicast functionality. We don't have broadcasting in v6, but we can still multicast out. So we can still talk to a DHCP server if we want to and get our IP address, subnet mask, default gateway, DNS server, domain name, just like we did with IPv4 in the IPv6 world. But we don't really need to do that. It's not such a big deal. If we think about the IPv6 address space, right? We did an example earlier, 2001.4860. Colon 0 colon 1 colon colon 12A colon I don't remember 1500, something like that. So the first 64 bits were network and the second 64 bits were host. 2 to the 64th, somewhere up over 18 quintillion somewhere. So 18 quintillion plus addresses to pick from. So if I know what network I'm on, why couldn't I just randomly assign myself an address in that space? What are the odds that I'm going to pick the same address as someone else? 1 in 18.6 quintillion or 18.6 quintillion to 1? So realistically, if I'm sitting down here as a PC and I'm connected to a router, why couldn't I just say, hey router, what network am I on? Let the router tell me what network I am. And from there, I can self-assign myself an address. I could do a duplicate address detection check just to make sure, but I'd be good to go. So again, I can get my IP address this way. It's standard for us to use a /64, and my default gateway would have been the router that talked to me. The only thing I'm missing here is who my DNS server is, what my domain name is, and any other perhaps company-specific DHCP options that are offered down to you. These don't change very often in our environment. We can leave these things as static. We could actually build our machines with the DNS IP address and the domain name piece, and I could get away from having to configure these, and then just let this stateless address configuration, auto address configuration be put in place. And that's what they built in IPv6. They built a functionality called SLAAC, S-L-A-A-C. SLAAC, S-L-A-A-C, Stateless Address Auto Configuration. So it allows me to say, hey router, what network am I on? Give myself an IP address, check to make sure that it's okay, and I have everything that I need. Now we could run a combination. What if you said, oh wow, well what if we want to change the DNS server? We can't use SLAAC. Well, you could still use DHCP simply for the DNS, domain name, or any other options that you wanted, and let your machines do a stateless auto configuration so that at least be able to talk on the network, and maybe you could have a fallback of a static configuration if you needed to. So we can use a static, fully configured. We can use DHCP for V6 for a completely automated functionality through a server where we control everything, or we can use this combination of Slack and DHCP to give us some sort of a hybrid configuration. Again, looking at the configuration for IPv6, it can be as simple or as complicated as you want it. Let's make it simple. Let's use the stateless auto configuration and maybe even hardcode DHCP values, or let DHCP supply my DNS values. IPv6 is the way to go.